Hey everyone, my name is Ella and I am a first-year undergraduate student at the University of Victoria. Today I will be taking you through my Geography 103 Fluvial Geomorphology lab, in which the stream system I have chosen to discuss is the mighty Fraser River. As the longest river in British Columbia, there are obviously many channels, and thus I will be focusing my report on the tributary that flows just south of Richmond, BC. Unfortunately, due to COVID restrictions, I am unable to visit, so I will be taking you guys there virtually. So, zooming out a bit, you can see here that the river originates in the mountainous areas of eastern BC and flows west until reaching the Strait of Georgia. The headwaters of the river are located around Mount Robson in the Rocky Mountains, just west of the Alberta border, in which it starts as a fast-flowing stream, picking up sediment along its path and beginning to appear brown as it goes around the Columbia Mountains and towards the coast. So, looking at this map here, you can see that the river comes out of the mountains and then flows over flatter terrain once reaching the lower mainland near the coast, which is my localized area of study. The result is that it slows down and spreads out, forming various branches. At the lower reaches of the Fraser River, as it passes Greater Vancouver and Richmond, it is considered a braided stream, which is a maze of interconnected channels formed on a river with high sediment load. This can be seen in the river's multiple outlets emptying into the ocean, as well as an estuary at its mouth, seen here, surrounded by a large plume of sediment cloud. So, in regards to the local climate, at the lower reaches of the Fraser River, there is a bit of overlap in the region between a CFB climate, the bright green, and a CSB climate zone, the mustard yellow. However, for my local area of study, that being specifically the South Richmond Channel over here, the most accurate Köppen-Geiger classification is CSB, which is characterized as a temperate to dry climate. It is commonly described as a warm summer Mediterranean climate in which the coldest month averages above 0 degrees Celsius, all months have average temperatures below 22 degrees Celsius, and at least 4 months average above 10 degrees Celsius. Looking at this climograph here, it is visible that the highest temperatures fall around midsummer, so in the months of July and August, while conversely, this time of year sees the lowest precipitation compared to the winter months, which see the highest precipitation. Looking at this hydrograph, depicting seasonal patterns in discharge, we can see that for most of the year, discharge patterns are relatively stable, especially during the winter, and precipitation does not really cause much of an increase in discharge. However, there is a big seasonal spike in discharge at the beginning of summer, peaking around June, which can be attributed to the spring snowmelt in the alpine regions of the headwaters of the Fraser River, when temperatures rise and there is a spring thaw at higher elevations, melting the snowpack and increasing the amount of discharge entering the stream system. I already mentioned this before, but closer to its headwaters in the Rocky Mountains, the Fraser River starts as a fast-moving stream. As the Fraser River flows over flatter terrain and the topographic gradient decreases once reaching the lower mainland near the coast, this results in the channels slowing down and spreading out, although it is not a true meander, as there are a few sinuous curves that are well defined. However, it does result in a branching pattern and the river spreading out. The first feature I am going to discuss with you is the formation of an island by the river, specifically Shady Island, seen here, just off of Steveston Pier, which I highlighted in white and will soon be taking you to. So here I am, standing at London Park, just next to the pier. As I look across the main channel of the river, you can see the main bank on the very far side, and then just looking down to my right, looking southwest, you can see a closer piece of land, which is actually the so-called Shady Island. The small channel between me and the island is called an anabranch, which can form and return to the main portion of the river downstream, forming an island between the two channels of the river. Looking at this from a bird's eye view, again keep in mind my position standing in the white square, between Shady Island and Richmond is the smaller channel of water that rejoins the main river, forming Shady Island. Island formation by rivers, as such, happens when the topography is generally flat, such as here in the lower mainland, so that the river slows down and is able to branch out more. The second feature I'm going to discuss is the formation of a delta by the river, called the Fraser River Delta. I have highlighted my position in white again. Specifically, I am located at the viewing tower of the Alaskan National Wildlife Area, which is on the Fraser River Delta and is home to migratory birds and many endangered species. A river delta is a landform created by deposition of sediment that is carried by a river as the flow leaves its mouth and enters slow-moving or stagnant water, such as when a river enters the ocean, for example. Essentially, the Fraser River discharge is also laden with silt and sediment, washed down through the Fraser Valley. The speed of a river slows when it meets a standing body of water, like the Strait of Georgia. It consequently loses the force needed to carry material such as gravel, sand, silt, and clay collected throughout its journey, and these particles, also called alluvium, settle on the river bed. Over time, sediment accumulates and forms land. The third feature I'm going to discuss is the formation of a floodplain, which I'm going to demonstrate at Brunswick Point, highlighted white. The flat, low-lying area adjacent to a meandering channel and subjected to recurrent flooding is a floodplain. It is the area that is inundated when the river overflows its channel during times of discharge, such as during the peak of spring snowmelt. Richmond technically is located on a floodplain, as many areas are actually located below sea level, and the municipality has managed to avoid damage from flooding through the creation of dikes and the use of other technology. You can see here in this image that beach logs have actually washed up right on the path, while the ocean and current river channels are relatively far away, which you can see all the way in the distance. So floodplains can be caused by erosion or deposition of the river. However, in this case, the floodplains or the Richmond Delta have been formed by sediment deposition. To conclude, the Fraser River, like all stream systems, is dynamic and changes over time. The places I showed all of you today and the features created by the river have not always been there, nor are they likely to remain in their positions for long. Furthermore, from mountains to the coast, the Fraser River changes drastically from its headwaters as a swift-moving stream with rocky bottom to a branching, slower-moving channel with high sediment load upon reaching the flat lower mainland, allowing it to form the features discussed, such as deltas, islands, and floodplains. I believe my learning in hydrological processes, as well as my understanding of my local area and the dynamic nature of its form and function, was greatly enhanced by this fluvial geomorphology lab. Despite not being able to practice this in the field due to COVID restrictions, I've taken away many tools I learned to be able to assess climate effects on stream systems by creating climate graphs and hydrographs, as well as evaluate topographical and human impacts on my surrounding environment. Thank you guys for watching.